Okay, so now we're going to look at still finding a quadratic equation with a given set of solutions, but now the solutions will have terms involving roots or complex factors. So we're going to be reversing the process of when we solve using square roots. So when they have roots or complex factors, we're going to combine the equations into a single equation and set x equal to that solution using the plus and minus notation. Then we'll isolate the term with the root or the complex factor. And then we'll square both sides of the equation to get rid of that root or complex factor and set the result equal to 0. So this will be easier to see as we look at a couple examples. So find a quadratic equation with the given solution. So this one has root solutions, x equals negative root 3 or x equals positive root 3. So the first thing I want to do is combine this to a single equation, x equals, using the plus or minus notation, plus or minus root 3. Now I want to isolate the root, or you can think about this as isolating the plus or minus term. So I already have that done in this situation. And then I want to square both sides of the equation. So come back up here. We square the left side of the equation. We square the right side of the equation. When we square the plus or minus, a positive squared is a positive, a negative squared is a positive, so that plus or minus goes away. And we get x squared equals, well, root 3 squared is 3. And we're done. All we have to do now is set this equal to 0. Technically, this is a quadratic equation with those two solutions. So we wouldn't actually have to set it equal to 0, except that's what it wants us to do. So you get x squared minus 3 equals 0. And that equation has those two solutions, negative root 3 and positive root 3. Similarly, any multiple of this equation would also have the same solutions. I could make this a little bit harder by, looking at another example where instead of just having it equal root 3, we could have, say, x equals 2 minus root 3, or x equals 2 plus root 3. And in this situation, again, I would want to take these two equations, combine them into a single equation using the plus or minus notation. So I would get x equals 2 plus or minus the square root of 3. So that would be our first step. Our second step would be to isolate the plus or minus term. So that's this plus or minus root 3. So to do that, I have to subtract 2 from both sides. And then to undo the square root, we can square both sides of this equation. So step 3 is to square both sides. So here's where I really need these parentheses, because I'm not squaring just an x now, I'm squaring an x minus 2. So when I square the right side of the equation, the plus or minus goes away. The root 3 squared becomes a positive 3. This left side of this equation, however, has to FOIL out. So I have to be a little bit careful over here. I'm going to get x squared minus 2x minus 2x. That'll give us a minus 4x. And then negative 2 times negative 2 is positive 4. X squared minus 4x plus 4 equals 3. And then so that is an answer. That's an equation, a quadratic equation with those two solutions, but generally you want to set that equal to 0. By subtracting the 3 over, and you get x squared minus 4x plus 1 equals 0. And you could kind of see, if you look at this process in the reverse, this is the process of completing the square backwards. If we start at the bottom down here and we work our way up, we move the 3 over and add plus 4 on this, well, really you move the 1 over and then you add something to both sides. Then you, well, okay, it's the reverse. It's harder to explain going backwards, but you could kind of see it going back up, that it is the reverse. Okay, now we'll look at a couple examples with complex solutions. It's the same thing, except that when we square, when we get an I squared, we recall that I squared is -1. In this situation, we have x equals -2i, or x equals +2i. So I want to set that up with a single equation using a plus and minus. So I combine these together to get x equals ±2i. Then I want to isolate that plus or minus term on the right side of the equation. That's already done because there's no other terms involved. So now I want to square both sides of the equation. So put these both in parentheses, square them. You know, I don't need the parentheses on the left, but it's just a good idea to keep them there for now, because when you have some other term there, like we saw in the last problem, it has to FOIL out. In this case, it does not FOIL out, it just becomes an x squared. Now on the right, what happens? Plus or minus goes away because a positive squared or a negative squared both become positive. 2 squared is 4, and I squared is I squared. So we get a 4i squared there. I need to then recall that I squared equals -1. So I'm using that I squared is -1 here to get x squared equals 4, and then we set that equal to 0. And we're done. X squared plus 4 equals 0. And you could kind of, well, again, I was going to say, if you go back up, you see this in reverse is solving by using square roots, but I don't need to here. We'll go to one more example. Feel free to pause here if you need to stop this. And then my final example has x equaling 3 minus 2i or x equaling 3 plus 2i. So again, we recognize that it has roots or i's, and we combine to a single equation utilizing the plus or minus. So pull those over, plus or minus here. I get x equals 3 plus or minus 2i. And then I want to isolate that plus or minus 2i term. So that means subtracting 3 from both sides of this equation. So I get x minus 3 equals plus or minus 2i. And now I want to square both sides of this equation, which will get rid of the complex part of the solution, the I. It also gets rid of the plus or minus, because a positive squared is a positive, a negative squared is a positive. Okay, so when we square both sides of this equation, we have to be a little bit careful. Let's do the right side first. Positive and minus squared becomes positive. 2 times 2 is 4. I times I is I squared. That I squared will get replaced with a -1. So this will be -4 on the right side of the equation. On the left side of the equation, we have to FOIL this out. So I'm just going to, x times x is x squared. Get a minus 3x and a minus 3x, giving us a minus 6x for the inner and outer terms. And then -3 times -3, positive 9. So we get x squared minus 6x plus 9 equals -4. That is a quadratic equation with those two given solutions. There's a final step here, and that's to set it equal to 0. And we do that by adding 4 to both sides. So x squared minus 6x plus 13 equals 0 is a quadratic equation with these two complex solutions. And again, I could multiply this whole equation by 2 or by 10 or by 30. So there's actually infinitely many quadratic equations that have those two solutions. This is the simplest one, or the the one that we can get the easiest. Okay, so that does it for that section. Going backwards, when you have the solutions of a quadratic equation, there essentially are two different methods that we use. One that involves when the solutions are whole numbers or fractions, and the other when the solutions have roots or complex factors. So the ones we just looked at had roots or complex factors. We combine the equations to a single equation, setting x equal to the solution using a plus and minus notation. Then we isolate that plus and minus term. Then we square both sides of the equation, set the result equal to 0. In the first set of examples, when you have whole numbers or fractions, you set x equal to the two solutions, getting two equations, and then you multiply by the LCD to clear the fractions out, set each of those equations equal to 0, gives us the factors, and then multiply those factors together and set the result equal to 0. So in both cases, regardless of which of these two scenarios you're in, essentially you are undoing the process of solving a quadratic equation, which makes sense because in this section what we're given is the solutions, and we want to find the equation that has those solutions. I'm going to go back to the last problem we did, just in case someone didn't have a chance to catch it, and you can pause the video so you can see that whole thing.